Login accepted.
Okay. Hello, everyone. Welcome to my talk, which is called Is Li-Fi the New Wi-Fi? My name is Jullia. I'm coming from Bucharest, Romania. I'm a Java developer at ING Bank, Romania. From time to time, I'm also a trainer. And since college, I developed a passion for Internet of Things, robotics, and anything regards sensors and actuators. And before starting, I must also tell you that it's my first time as a speaker, so if you would be closer to me, you can see that I'm shaking a little bit. So I'm really sorry for my emotions. So today, I want to talk about this passion that I developed during the college, the Internet of Things stuff and sensors. And I would like to present to you what I've done in the last period. So I'm going to talk a little bit about VLC, what is Li-Fi, what is Li-Fi versus Wi-Fi, and of course the applications where we can use Li-Fi. And all started with the question, what can I do in order to have an indoor precise localization? Because I wanted to develop a system that was capable of localizing a person or a thing really, really precise, with an accuracy less than 1 meter. And by researching how am I capable of doing this, I discovered some interesting information. And for example, do you know how many mobile devices are worldwide? Well, there are 15 billion, which is a pretty large number. And do you know what is vital for all these devices nowadays? The wireless communications. And we are exchanging a lot of data between these devices, huge data actually. And because the number is still increasing, also regarding the data, also regarding the devices, these wireless communications have also some problems. We encounter some problems with them. And one of it is the capacity, because all wireless communications are using the radio frequencies. And all these radio frequencies are limited, are expensive also. And because the number of devices is increasing, we are basically running out of spectrum. And we need to do something, because otherwise we won't be able to use anymore the wireless communication. Further, the availability. And we all know that we need to change the phone to airplane mode when we are traveling with the airplane. And there are also some other places where the wireless communications are not really working. And for example, in hospitals, because there are some medical systems that can interfere somehow with our devices, and this is the reason why we should turn them off. And interference, yes, is another problem, because the wireless communication can penetrate walls, and because of this, they can be intercepted and hacked, of course. So the security, it's another issue. And then I was trying to figure out what is the solution to all these things, because I really wanted to do something with my indoor localization system. And I discovered that the solution is pretty simple: light. Light can help us a lot, and light is our life. Light is everywhere, even here, even in our homes, to workplaces, basically anywhere we have light. And communication via light isn't actually really new. The visible light communication, the term and the concept of visible light communication, was first developed in 1880 by Alexander Graham Bell, which actually developed a system which was called photophone, capable of transmitting voice by simply modulating the sunlight. And he actually managed to do this experiment, and the distance between the receiver, the emitter, and the receivers was somewhere around 213 meters, which is pretty awesome. And then, in 2011, the professor Harald Haas coined for the first time the term Li-Fi, which comes from light fidelity. He basically coined this term at the TED Global Conference, and he said that we can transmit data over light, especially over a LED bulb. And researchers have demonstrated that with this light, we can send data really fast. By using a blue light, we can send 3.5 gigabytes per second. And with a white bulb, we can send 1.7 gigabytes per second. Pretty fast, I would say. And then, theoretically, the speed can go higher, and this would be up to 224 gigabytes per second. But how is this possible? It's all about the visible spectrum, which is 10,000 times larger than the radio waves that we currently using in our wireless communications. And this visible spectrum is actually enables us to send data faster and to also allow many more devices to connect and to exchange data. And Li-Fi, what is this? How is this actually working? Well, first of all, we need a LED bulb. And why a LED bulb? Because has two basic properties which are important in this system, which is the intensity, because it can be modulated really fast, and the speed that we can use to switch on and off this LED. And this on and off activity enables us to transmit data by using binary. So basically, as an emitter, we will need a LED bulb, a driver that could be able to switch on and off the LED bulb so fast that the human eye can not even notice it. And then we need a receiver that should be a light sensor, a photodiode, or a solar panel. So anything that can detect the changes of the light bulb that is happening during the data transmission. And I repeat, the human eye cannot even see those changes. And to prove that this is actually really working and this is a concept that can be used in future, I have two systems that I want to show you today that I have tried to develop in order to show you that the data transmission is possible via light. And the first of it, I will do a demo by connecting a solar panel. So for the receiver, I have a solar panel which is connected to a speaker. And then I have a LED bulb. I really hope you can see it. A blue LED bulb that is connected to my phone, from which I'm going to play a song. The LED bulb is also connected to a power battery because he needed some energy. And what I actually want to show you is that it is possible to send all information, which is the music actually, from this emitter to this receiver. But first, I need to tell you that my system isn't perfect, so it might have some interferences with these lights. But anyway, I will try. If not, the second demo will definitely work. So I will switch on first the speaker. Then I'll try to play something. Now the LED bulb is actually sending information, but it's not blinking. It's blinking so fast that the human eye cannot notice. And now, if I'm turning the solar panel, and now, if I'm taking off the LED, the song won't play anymore. And again. And of course, I have some interferences. The intensity of the light also depends, but it is possible. It is possible to send data via light. It was really awesome for me. And further, I tried to see what I can do more. And I wanted to understand a little bit what are the differences. And the light fidelity, is basically using the light. Wi-Fi is using the radio signal. As I said, the Li-Fi can transmit data really fast, while the Wi-Fi, until now, it's up to 2 gigabytes per second. And then the frequency. This is the key, actually, in our solution. The Li-Fi has the 10,000 times larger frequency than the Wi-Fi, and this is the reason why we can send so many data in such a faster way. And then, regarding the security, light is stopped by opaque objects, so it doesn't go further through walls. Regarding Wi-Fi way, where it can actually pass walls, and then it can be interfered and intercepted, and so on. And the range in Li-Fi, we can have some 10 meters regarding the range, but of course we can extend the range by creating an array of LEDs. And the data density, which is also important, the Li-Fi works really well in high dense environment, like water. Wi-Fi cannot pass in water, but Li-Fi does. So, as an advantage, speed. It can send data really fast. It can be secure because it cannot pass through walls. Availability. It can be used in places where Wi-Fi cannot be used, like airplanes. Energy efficient. For radio signals, we need all those radio antennas that are really costly. While using data via light, we only need LEDs, which are not that costly, let's say. And then the capacity, because we have a larger bandwidth, we can accept many devices without affecting the speed. So, it can be used in water explorations, this Li-Fi. Then it can be used in offices, and different buildings, homes, museums, supermarkets maybe, in order to find faster something. In traffic, because why not? Cars would be able to talk between them by using and to exchange data by lights, and also to exchange data maybe with traffic lights. And of course, in airplane, would be easier to stream data, let's say, in airplane. And for the second demo, what I have done, because I'm still trying to find a solution for the indoor localization, but I just need to do some baby steps. The first step that I have done is to create a system with an Arduino board, to which I created the emitter and the receiver. The emitter has, of course, the LED, which is here, and has also a MOSFET, and so, of course, resistors in order to enable me to switch on and off really fast. And for the receiver part, I have a light sensor, I have an operational amplifier, and another component that enables me to adjust the sensitivity of the sensor. And of course, resistors, and all of these are connected to an Arduino board. And if I further going to connect this Arduino board to my computer, I don't know if you see it, but the LED is now on. It is sending data, and I'm going to open the serial monitor. And this is, oh, a little problem. Okay, so I'm sending just a string, it's a text, and if I'm going to cover the LED, the data won't be received anymore. If I'm going to take the hand, the data is sent. So this is a demo of how you can send data via light. For now, it's just a text, but in the future, I would like to send coordinates in order to do this this indoor localization. But as I said, I am taking some baby steps, and this would be the first step that I have taken by sending a text via light. So that would be all from my side. Okay. I would like to thank you. Do your thing, and if you have questions, you can find me here. Thank you very much.